Hello class, this is a video tutorial on the area between two functions, and in this video series there'll be 5 different examples going through various scenarios that you might find yourself when finding the area between two functions. So let's get straight to it. When calculating the area between functions, we must be able to visualize through sketching the area being calculated and calculate the boundaries via simultaneous equations. To calculate the area between functions, we calculate either the sum or difference of two integrals, always being mindful of the sign of the integral. So for this one, this is an example of the sum of integrals. So if we wanted to find the area below these two curves, we'd have to find the area from A to x1, so this area here, and then to that we need to add the area underneath this curve here. From that we can just find the sum of the integral. If it's the area between two integrals, we need to first find the point of intersection, and notice how if we find the area below the straight line, so this area here as shown here, and from that we subtract the area below the parabola as shown here. So if I visualize it, we're actually subtracting that area. Notice how we are actually left with this area we are looking for. So that's the top function minus the bottom function. You're going to see more of this in the next example, but this is an example of the difference of integrals. So we have either the sum or the difference of integrals. So let's get straight into an example here. Sorry about that, that's me just practicing. You can go ahead, pause the video and take a look, but here we go. The first thing that we needed to do for a question such as this is we need to find the point of intersection. It's currently already given to us, but let's work to prove that that's actually going to be x equals 2. Well, to do that, we're going to let these two functions equal one another. So we get x squared equals x minus 4 all squared. If we take the square root of both sides, we get x equals x minus 4. Notice that's actually not going to work. So let's actually just expand first. So x squared equals x squared minus 4 expanded becomes x squared, double the product, minus 8x plus 16. Cancelling the two x's, we get 8x equals 16. X is equal to 2. So that point we have here is indeed x equals 2. Now to find this area, we're looking for the area below this first curve. So area 1, let's call it, is the integral from 0 to 2 of x squared. To this, we're going to add the area, so area 2. Area 2 is the integral from 2 to this point here, which I hope you can see is going to be 4 from this transformation of, since we've already expanded it, let's use the expanded form here. That's x squared minus 8x plus 16 dx. Sorry, I forgot the dx there. And all I'm doing there is finding the area below this curve here, which is expanded prior. So now it's just a matter of integrating both and adding the solutions of both of them. Well, area 1, we can find the area of, increase the power by 1, divide by the new power from 0 to 2. Substituting 2, that becomes 8 on 3 minus 0 on 3. So we don't need that. So it's just 8 on 3 for area 1. Area 2, slightly more difficult. Increase the power by 1, divide by the new power, minus. Increase the power by 1, divide by the new power. So 8 divided by 2 is 4, plus, if it's a constant, we just give it a letter, which is 16x from 2 till 4. This is now just a matter of substituting the values of 4 into all the x's. So let's just copy this in. And instead of x, we're putting the number 4 into all of them. And from that, we're going to minus the exact same thing, but instead of 4, we're going to put in the number 2. This is just a matter of using your calculator for this. So I'm going to use my physical calculator since it's a lot faster than writing. So 1/3 bracket 4 to the power of 3 minus 4 bracket 4 squared plus 16 bracket 4. So this first one is going to equal 64 on 3 minus, going through, replacing 4 with 2. We should get 56 on 3. 64 on 3 minus 56 on 3, we get 8 on 3. Now to find the total area of the entire thing, it's just a matter of adding both of them. So the total area is just 2 lots of 8 on 3, which is 16 on 3 units squared. That's the first example on calculating the area between two functions using the sum of two integrals. Hope to see you in the next video where we do lots more examples, and best of luck.